Hi guys, in this video we're gonna talk about the different ways that you evaluate LLM outputs. It's really important because you want to know that the responses that you get from LLM, is it grounded, is the result truthful, is it harmful, and so on. So in this video we're gonna take a sneak peek into the main different evaluation methods that are provided for LLM, and we discuss and deep dive into one of them to see that exactly how it's look like. So it really matters that we make sure that the AI is not just making stuff up, or the problem of hallucination that we have heard a lot about this. And there's also another term for evaluation, which is basically we want the information to be accurate. For example, if we are asking about a specific information that exists in a document, we want the result that we want from it to be completely correct. And sometimes we are doing some task like summarization, we want the main pieces of information to be extracted, or we want a specific type of output, so we want the format to be followed by the structure that we want. For those of you who are new to this channel, my name is Pedro. I have a PhD in computer science, and in this channel we talk about AI and machine learning and how we can use it in order to improve our efficiency. As we mentioned, it is really important to know that the LLM is evaluated correctly, because we don't want to get bad advice, especially as of right now that we receive and count a lot on AI. We want to make sure that this information are correct and accurate, so we don't want to get confused or wrong a result, and also we don't want to get nonsense or the responses that are meaningless, and also it shouldn't be biased, which is actually another important factor. It should be faithful and also generate equal outcomes in different results. So all of these, or basically consistency in the output, are mainly the problems of LLM because of their ability that they are generated based on the probability of the next output token. So there is always a level of uncertainty in what's going to be generated. We will have talk about what makes AI good, and these are the four main important pillars that make an output of AI good. So it should be fluent, coherent, so natural and sensible language, so in a way that human can connect to. It should be relevant, which means that if it is question answer, you should answer the question rather than providing an irrelevant answer, even though if it is correct. And it should just stay on the topic, and it should have factually consistent, which means that it should have truthful in the response and no contradiction, and also it should be fair, so avoid harmful biases. There are mainly two reasons to do evaluation. One is doing human evaluator, and another is to use automatic one. So the problem with human annotator is that it's going to be a manual check, and human can read and basically use their judgment call in order to provide the response for us, and it can be time consuming and definitely not scalable. But on the other hand, we have automatic check, so we want to have some shortcut for efficiency, and it should handle a large volume of data, but definitely we need to make sure it accurately reflects what we care about as humans. So for that reason, it's really important to know what are the quantities that we care about the quality of the response. In terms of automatic grading, there are basically again two different approaches. You can basically have a reference response, and then you can have no reference. So in the first style, we have a reference-based method where they provide a ground truth, and you can compare it against those. So these can compare outputs to human perfect golden responses, and you can use different methods. This is conventional natural language approaches, such as the ones in character level like level sign, or you can use word level like BERT and BLEU. And these ones actually try to see and count the words and match the phrases to make sure that it actually contains and is relevant to the annotations that we propose as our golden information. On the second slide, we have a reference-free methods, which basically they are going to ask, does this information make sense, or does it answering the question? So there are no answer key necessarily given, but it provides some rubric to measure and gauge the response. So we're going to judge the logic, coherence, and helpfulness. We get deeper into reference-free three methods. We have reference-based method, as we mentioned. We have n-gram methods like BLEU, ROUGE, JS divergence, and we have embedding-based, which basically try to find semantic similarity, like BERT score, mover score, sentence mover, and similarity. So the difference between these two is that both of them has reference, but in the semantic similar one, you don't necessarily look at the exact word, but you are looking at something that semantically have the same meaning. And sometimes this is actually makes sense because LLM, as we mentioned, can generate, instead of the exact word, you can generate some synonym of that, and in some cases it can actually completely make sense and completely be true. And then on the other hand, we have reference-free metric, which are quality-based metrics like super blank, ROUGE C. Then we have LLM-based metrics, which are which can be both reference-free or reference-based, but these are basically prompt-based, and you're gonna do different prompting to actually ask an LLM to provide the response for you. So you're gonna consider the same scenario as LLM as a judge, and we will deep dive into them. As now, the main question is, as we have so many methods, when we should decide what to choose. So you're gonna choose it based on the task and the data available that you have. So the reference-based method, if you have the ground truths and there is some information that should be exactly that or something similar to that, so you can basically use that. But there are so many cases that you don't have the ground truth, or it's hard to get, so that's one where you go with the reference-free methods. So here is a good diagram to take a look. Like if you have access to reference, and you're gonna say, is there any one correct answer for that? And then if answer is yes, so you're gonna ask, is it a predictive task? And if it is yes, then you can take a look at some ranking method, some classification like precision recall, F1 score, and then we have regression, RMSE, and so on. And if it was not, you're gonna do some deterministic match like the exact match that we talked about, or string match, and then output validation if it is like code generation. And if it was not one answer, then you can use overlapped based metric, semantic metric, or LLM as a judge. And if it was, we didn't have any basically reference answer, we're gonna see that there is there any objective quality? If it is yes, so you're gonna do programmatic validation or structure adherence. These are when we want a specific format for the output. For example, we want a JSON, that's where we want to make sure that it follows that format. Or is it we can use, if there wasn't any specific quality objective, then we can look at LLM as a judge, regex methods, ML method, and text. If you want to get more information about each of these, I put the link in the description where I actually create a blog to explain each of these and provide a link to get more information on that very important topic of AI judging. AI, this is actually very prominent right now as the AI got become more and more powerful. They are using in order to judge the responses from the AI. So you can have it reference based or reference free, as we mentioned. So there are some pros and cons of it. So the pros is that it can have faster evaluation, it is highly stable, and it can handle huge volume, so it can basically easily scale up. But the cons is that it has potential for AI judge biases because of the training data that it has, and it has reliability concern, as we mentioned, because of the not consistency in the output, and then it is difficult to understand the different nuances. So you really need to make sure, and also it comes with some cost, obviously. So you really need to make sure and compare these two methods, the pros and cons, to see that is the LLM as a judge a right solution for you or not. I'm gonna talk about the different tasks and what are the different metrics we can use for each of them. For example, the first one is summarization. This is the one that mostly lots of people generate lots of reference-free method for that. So the task is that you have a basic text, you want to summarize the key findings from it. And so what we want it first to be accurate, and it wants to capture the main points. And so we can use the ROUGE, which is basically the word overlap. It wants to be faithfulness, so we don't want to generate any new facts, and we want to have a coverage, which means that no important fact should be missed. In order to make sure that we understand the metric, we can take a look at lots of the reference-free methods which try to address this summarization task. Then we have Q&A methods. So Q&A is that you have a question and then you want to answer based on the related information that you have. The task is that the goal is that we want the information to be correct and we want it to be relevant. So we again can have exact match, but if we need to know the factual response, we can go even into a classification task. So take a look at the F1 score, precision and recall. And after that, we also have something for code generation. For example, it can be Python code generation or SQL output response, or something that you require a specific format. So this one's is important, that we want to make sure that the code working and it is human-like. So there are different metrics that can be used in here. There are functional correctness, and we want to be executed accuracy. There are so many methods in terms of taking a look at the structure and the outputs or the grammar of the structure of the tokens that are generated. These are completely separate topics that people focus on, how to make sure that the output is JSON compatible, or how to make sure it is a Pythonic output, and so on. And there is definitely a line of work on that. Faithfulness, we already have talked about it. It comes across so many approaches, such as summarization, Q&A, and even RAG, or retrieval augmented generation. So we want to know that, are we generating any hallucination, making stuff up, or is it actually grounded? So this is a very important topic. I want to talk about one example and one method that we can actually use in order to do that. So we're going to take a look at reference-free methods in here. We don't want to have actual output that can be considered as a golden truth, and then we can compare it. We're going to say that, okay, we don't have access to that. One of the ways is actually FACC. So FACC is one of the methods that try to solve this problem. Let's take a look at the step-by-step approach for that. If this is too much for you, don't worry. We're just going to dip a little bit dive in here to understand exactly how the FACC work, but then if you don't completely get it, that's completely fine. You can take a look at the description of the video and you look at the more related content there to get more information. So the first step is that we want to generate answers from the source doc, and how they do that is try to generate some synthetic data, and the synthetic data include both correct and incorrect, or grounded and non-grounded responses, and then those synthetic data are labeled, so they use these as their instead of their ground truth, and then we're gonna broke the answer into individual claims. So we provide an answer, they want to divide it into different claims, and then for each claim they want to make sure that is it existent in the original source or not. And how they do that, they can use something like a BERT that is basically fine-tuned for a classification task of is it grounded or not, based on this synthetic data. So they try to fine-tune this BERT to basically recognize this factual information that this segment doesn't exist in this, and generate a true or false, and then they're going to use this BERT again on the actual data in order to make sure that each facts are from it or not, and then it provides a score. It can be either true or false, or it can be the confidence level, and based on that they're going to make sure that is it faithful or not. So we can see the approach that they are doing in here for reference free, and you can see that you can draw a parallel connection to basically the AI driven approaches, or asking the LLM as a judge. It's going to be very similar. Like the BERT that's in here was fine-tuned to detect that is going to be something somehow baked in already in an LLM, and can provide a good response if you provide a good prompt for that. And then here we are comparing it against other ones, so it has overall quality, coherence, and style. And in this one we were focusing on factual support by the source and detect made-up facts. So there are other methods like BLEU and ROUGE. It just compare at the overlap. It doesn't necessarily cover all of the nuances. And there you have it, guys. We went over LLM evaluations. We first discussed why is it important, and then we went over what are the different approaches to do evaluation, and then we talk about the reference-based and reference-free, and talk about the LLM as a judge, and then we deep dive into one of the criteria for evaluation, which was faithfulness, and we see that how it's done in a reference-free style. If you enjoyed this video, make sure to like it. More importantly, subscribe to the channel so you get more information like this. Make sure to watch this video that I created before about NotebookLM, which is a solution to handle the hallucination problem, or you can watch this video that I talk about vibe coding and how you can get a start to become a vibe coder, which is the new area of coding and building apps. Thanks for watching, and see you until the next one.